Okay, 1, 2, 3. Okay. All right. Okay, so I'm not Steve Jobs. I don't know those things. Today, I've been asked to present something interesting. So my presentation is going to be going back and forth between the actual presentation and some videos which I put together. I'm here to talk about different methods of doing the live production. And we all know that 2110 became very hot 6-7 years ago. And everybody was saying SDI is going to die and we're going to have 2110 all over the place. Well, 2110 is, in fact, becoming more popular, especially on the new installations, but SDI did not die, it just transformed with the fact that 12G SDI became more prevalent and acceptable in many different places. But beside that, we also have a cloud-based production which is coming strong. So I'm here to talk about all three different medias which are being used for doing live production. EVERTZ was one of the first company, if not the first company, which actually introduced the uncompressed video in live production, with ESPN being the first one. And once again, I'm going to switch to the website and just let you listen to that. Just before I switch to the video, I want to let you know that the first ever install was done in 2013. That's basically 12 years ago. It was ESPN Bristol, and that's where we put the first two EVERTZ fridges. That's what they've been called, 40RU IP switches with blackbursts going into them. And it's still on air now, so it's been a long period of time. So this is the video. Tested it. Anyway, so this is the large facility which has
94,000 square foot facility. At the same time.
Yeah, so it's two EXC1s and two EQXMs together, and then EQXMs were built just in case because SDI was as a backup. And just to see how it was all built, we actually have JPEG 2000 as a main this signal going on up to 13,000 signals throughout the entire facility. All the multi-viewers are JPEG 2000, all the signals are going to go to JPEG 2000, and in fact, all the columns inside the building, all the back sets are done on the same SDVN system. So that was the first EXC built, and from this point on, we have built lots of IP systems. So on the ST2110, there's other wonderful customers, and I'm going to be talking about them in the presentation. But this is the ESPN first ST2110 and JPEG 2000 facility, and it's still going strong. So if we're going to go back to the presentation, I'm going to switch it on. And so EXC1 and EQXM, which was also 2110 facility. Apart from that, we built Fox, Tempe, and 2110, and everybody probably here knows that particular facility. It's fully based on EXC, initially on the EXC1, and now it's actually working on EXC2. SoFi Stadium was our first work with the COT switches. So because SoFi uses Cisco as their corporate sponsor, we couldn't put our fridges anymore. So we had to teach Cisco how to do video. And it was a 2-year process. During those 2 years, we had to explain that it's not okay to have the signals going one after another and take 5 seconds to switch. We have to explain how important that audio actually matches the video, and they've done a pretty good job. So right now, I would say the so-called COD switches are on par with our systems as well. Another install which I'm very proud of is 49ers, Levi's. Diversified has actually built it, WJHW have designed it, we won it, and it's installed again with Cisco as a middle. The difference between the SoFi, it was a NBA passive. In Levi's Stadium, it's actually active, and we've done a pretty good job on using our orchestration system, Magnum, to operate all that different system. I'm lucky enough to be on a home opener game. I also just came back this weekend from the other game over there, and I see this control room, which is absolutely wonderful. This control room has 6 replay stations for the 2110 4K and 2 replay stations for the 8K. Yeah, by the way, 8K came in to football all of a sudden because one of the stadiums we put in the 8K system with a couple cameras around. And what happened was there was a definite home team advantage because there's certain rules in the NFL which do not allow the coaches to have some visibility of what has happened on the field. But with the 8K technology, we are able to use the operators to zoom in to a particular play and see if the player did have both feet on the field during the ball. Have 2 pictures, put it on a big, huge screen of SoFi or 49ers, and immediately the coach already waiting for that screen to be put up, and he sees it, throws the flag. So we've done 1 install with the 8K system, and after that, all other stadiums start buying it. That was a pretty easy sale for us. So this is the control room for 49ers. Just wanted to let you see what it looks like right now. It's first UHD end-to-end system. They have 18 UHD cameras throughout the stadium, which are standing side by side with the Obi truck cameras. They also take camera feeds from the Obi truck and upscale it to UHD. And on top of that, they have a complete UHD infrastructure which goes from start to finish all the way to the multi-viewers. It's an incredible production. It has 2 Grass Valley switchers, 1 for the main production, 1 is for the Spanish feed if they need to do it. It's very well designed by our friends from Diversified. So if you look at how it looks on big, huge jumbotrons, this is how it looks. It's incredible, it's huge, it looks amazing. The last game which I went to was actually a primetime game. So the halftime, they had an in-sync singer doing the song, and the huge speakers behind those jumbotrons were just amazing. Everybody around were just singing together, with the exception, of course, the younger generation who was in sync. Who are they? So it's definitely a very great system. Here's the little schematic done by EVERTZ for this particular system. It's pretty straightforward. You have a COD switch farm in the middle, and you have a lot of different components attaching to it. both EVERTZ and non-EVERTZ, but it's all ST2110. However, still, the design by DSI had the patch panel included in this particular design, because I think patch panel is still dear heart to any engineers for sure. EVERTZ does build multiple ST21 system. We do huge installs with Arista. The latest one was for Fox DPRT 1440, where we had Arista in the middle, Magnum overall, and a big, huge ST2110 edge device farm using 670 blades throughout the place, which could be multiverse, could be up-down cross converters, or could be actually IPGs. Beside that, this particular system in DPRTs also has a Dreamcatcher farm. Dreamcatcher farm originally, 12 years ago, were designed as a replace stations to compete with EVS. It became way more than that. So now we have actually a live switching platform based on the same idea, the same philosophy. And I'll be talking about later on, and I'll show you some examples of that. But just to let you know, Fox was the first company which deployed multiple Bravo stations to do the live sports production. We also have it in CNN. They're doing interesting things between Mexico and Atlanta. But Fox is something which I was involved in together with Daniel, and it also showed that the new technology is going to slowly go away from piano-based system to a touch-based system. Magnum is in front of all of that ST2110 system, and we always say that Magnum is important because it can orchestrate both ST2110 and SDI workflows. It can monitor what's going on, and then it also can analyze what is going to happen. So I'm not going to spend too much time on what Magnum can do, but this is just an example of how the interface looks whenever you interconnect multiple edge devices to the cores, main and redundant. Because SDI and ST2110 somewhat different. In SDI, we rely on a main redundant crosspoint. In ST2110, we don't need to worry about it because we just go to two different switches, red and blue. And we use so-called multi-packet mergers, or 2022-7, to make sure that any receiving device receives two streams with the same timing and just throws away unnecessary packets. It gives you a FEC effect, because if some packets are gone, it's going to be replaced, but at the same time, if the fiber gets cut, you still have the system working for you. Because we were so strong with the ST2110, we have to compete with some very good competition on the market. We also understood that in SDI world, we have to come up with something which is going to be able to compete with smaller guys. We're not going to be compete with the Blackmagic, but there's a beautiful suppliers to you guys, such as Ross, and we saw the sales going away with the Ultrix system. We always had EQ access, we had Xenons, and those Xenons, gosh knows how, but they're still working strong 15 years later, and I go to some stations and they're asking me, oh, can we get another card? And I'm saying, sorry guys, I mean, it's been out of production for the last 10. But it's one of the problems with the broadcast equipment. You install it and it just works. So, well, no. I'm not saying that it's plug and play. You install it, commission, and then it works. And then, but later on, when it gets old, obviously it does cause some headaches, and especially if you don't have replacement. So we have created a next router. The next router has somewhat a different philosophy. The next router is an SDI router based on IP, and we'll talk about that. But beside that, we also have our own switches. We call it purpose-built switches. There's a Arista, there's Cisco, and there is a NATEX. NATEX is something which EVERTZ built itself. We build our own silicon. And the only difference between the COD switches and EVERTZ built switches is the fact that our switches do have black burst coming into them, and they can clean switch on the switch. So 2110, whenever you have a 2110, you have to understand that normally with a COD switch in the middle, you will switch on the edge devices. And that means that if you need to have a clean switch, you have to make before break. You have to provide double of the bandwidth to the device so it can actually receive both of them and then switch. In EVERTZ world, because we have a black burst and we're frame aware, PTP is not frame aware, we actually can do clean switching the same way as we do on SDI. So there's different switches. There's light switches, which we call aggregation switches. It's not leaves. We call it aggregation. There's a regular switches, which is license-based up to 6400 gig ports in the 1RU. And there are more switches, such as NATEX 128, which is capable of doing in 1RU 4000 by 4000 3G switches. So you could see that number of RUs which are going to be in your equipment room are reducing dramatically. And I'll tell you how else you can reduce it further. We also introduced, and many of you know that EVERTZ does produce master clocks. We used to have 5600, 5601, then 5700. Now we introduced to the market, and we finally start selling it and installing it 5800. Imagine? Yeah.
Just curious on a switch like that. We know 2110, but also in the other world, in the corporate world, there's IPMX.
Yep.
Is there a hybrid use case that makes sense? And do you support such a hybrid? Guys, wait for the microphone because we have a passive audience. Try that again. CTFO. Hello, hello. Well, there we go. You poor individuals, you have to deal with a non-broadcast voice. With a face like this, I didn't have to go in. Just joking. Question is there's IPMX in the corporate side or the AV side, and there's ST2110 in the broadcast or production side. Is there a use case where the two converge?
Absolutely.
And do you support such a hybrid environment?
Well, of course, the whole idea of IPMX is the fact that you can actually use at the same time 2110 and IPMX on the same switch fabric. So not only we do support that, in my Burbank office this spring, we actually had a IPMX workshop where many different suppliers came in and did interop together to make sure that they're all working between themselves.
One more question. What's the benefit of using IPMX, and where would you use it in such a hybrid environment as opposed to ST2110?
ST2110 does not have such protocols as USB. It doesn't support automatic scaling, which a lot of AV appliances have to support. So IPMX just adding more components to it, and also it is capable, and then it actually was a fault of ST2110, capable of working without PTP. So you have ability to do both. So in an environment, whenever you have a broadcast plus IPMX, you will provide the PTP to all your devices to be in time. But in an environment when it's IPMX only, you can actually make it working without the PTP present. So to answer your question, we did show at various shows at NAB this year and at IBC capability of having ST2110 device delivering ST2110 directly to IPMX device and vice versa. And switch is irrelevant. It doesn't matter, like what you're going to use as a switch, because it's edge devices which have to be compatible. Okay, so I'm going to go further. So just to let everybody know, the 5800 is a thing. It's being shipped. The major difference is we finally got rid of need for Vista Link to configure that, or the front panel. It's an HTML5 web page, and you can configure everything. So it becomes a much easier task to do your configurations, to monitor your PTP, and actually logs the PTP faults right in it. It also has 2 GPSs per unit to make sure that if lightning strikes one, you continue working with the second one. And it does have finally ability to do 12G test generations, 2110 test generations, UHD, through 25 gig ports or 100 gig ports. And you can actually build your own test environment. So you custom test gen, you can build it as well. So going back to NEX. So NEX is the router which we initially built as a 12G SDI router. And we did not advertise that it's not a true SDI router in the very beginning, because we were concerned that the industry is going to be taking that with the same feel of that, well, it's IP. I don't want to do IP. I want to do SDI. So if you look at the next 5, we have several configurations. You have ability to do 12G SDI. It's a 12G SDI crosspoint, a single crosspoint. You can do SDI IOs, you can do 2110 IOs, you can do JPEG Access IOs, you can do up-down cross conversion on the same platform, and you can do embedded audio. So there's 3 different sizes of it. 3RU, 96 by 96, 12G. 5RU, 384 by 384, 12G. And I can actually stack 3 of 5RU together for the 960 by 960. And in fact, we've done installs like that quite a few places. What I like about the NEX router, it's in a very small form factor. You have ability to do processing. You can do 32 by 32 card can take 32 frame sinks. I can embed and de-embed MADI or TDM in any of those things. And each individual card can carry up to 4 standard multiviewers, 16 by 1. They are grid-based multiviewers. Apart from that, there's different blades which we introduced after we rolled out the NEX router. And by the way, we've sold hundreds of them since we rolled it out about 3.5 years ago. We have a blade which is capable of doing processing, whether it's advanced multi-viewing, which is your familiar pixel by pixel adjustments and all kinds of advanced monitoring. We have a blade which can take our Scorpion MIO modules, which becomes a Swiss Army knife. If I need to do just a single UHD to HD up-down cross converter with HDR, you just have a blade. If you need to do HDMI in, you have a blade. If you need to do Dante, I have a blade. So I can take Dante directly to this router in and take the Dante out. And by the way, the Dante in this case can become a master, because all of us know that audio is the most forgotten child in engineering world, because it's so complicated and people don't realize that. So Dante and normal SDI embedding usually very difficult to marry, especially with the new consoles which do not have a volt clock or black burst on them. And they feel that, oh, okay, I have a self-generating PTPv1. Well, sorry, the PTPv1, nothing to do with PTPv2. Mind you, Broadcom does added the PTPv2 capability on the newer versions of Dante cards, which hopefully are going to come in and start accepted all over the place. But what my point is, the next router can become a master for this Dante network, and then you're not going to hear the pops in audio. So next three is 96 by 96 cross point, 3000 by 3000 audio cross point, because you have audio embedding and de-embedding, and all of that could be interconnected with FX link. And because FX link, in a sense, is, some of you probably know about X-Link. That's how we took the EQX or Xenon and using the cross point, just instead of taking the videos directly from the outputs of your cards and feeding the multiviewers, we just connected one cable, well, one type of cable with a 32 copper things inside, and took it from the cross point, which was larger than the actual cross point needed for the router, and attached it to multiviewers, penalty-free multiviewing. So now, because we live in an IP world, we just use the 400 gig interconnects between the actual different next routers. And I can interconnect 5RU next router with multiple 3RU or 5RU next routers and build the entire system looking like a one single router, no tie lines. So I don't have to worry about, okay, I'm going to have a problem because my tie lines all filled up. No. All I'm doing, I have a big cross point on my master router, and I have a slave cross points which are going to be interconnecting different cards. So that's how it's going to be done. So what is next IO card? It has a 32 by 32 with a gearboxing capability. It can do anything from ASI all the way to 12G with licenses up to 12G. It has audio shuffling on it. It has integrated TDM or MIDI embedding and de-embedding. And you can have frame syncs. On a so-called C1 card, you will be able to do 32 frame syncs on 3G or 16 12G on the same card. We also have ability to build multiple multi-viewer layouts. They're grid-based multi-viewer layouts. And the way we build them, anytime something comes into my input, I create 3 different proxies, 3 different video pips sizes. And out of those pips are living in the cross point. Out of those pips, I can create multiple different multi-viewers. Each line card, so to speak, besides the fact that it can do 32 by 32, audio embedding and de-embedding, it also can carry 4 standard multiviewers, which are very inexpensive. It's like $4,400 list price, each 16 by 1. So it's like we're literally going down to the price of the Blackmagic if you were to need to connect multiple different things. It becomes very popular. And those different layouts are absolutely like this 55 right now, and it's becoming more and more. All you have to just worry about is going to be out of those 3 different pips. We're adding the 4th size. It's going to be a full size as well, because a lot of customers want to have a UMDs on them, full-size multi-viewers, and then this request came often enough that we'll actually add that capability too. So beside that, we have a 3 UMDs per pip, and those UMDs could be static, could be names from Magnum, or could be a tally state, image, video, or TSL5. It has a PCM audio bar, so you can choose how many audio bars you want to display, anywhere from 2 to 16. And you have ability to put the time code with the EVERTZ and NTP on this standard multiviewer. So once again, you have different things. At NAB, we introduced a different card called R1 card. And that card basically was a next evolution card. A lot of customers were asking, okay, what about fiber? You don't have fiber out. So we created a card which had double the capacity of FPG, and we've designed it in a way that you have a rear plate attaches to this particular card, and depending on the rear plate, it assumes a different function. It can become a 20 by 20 fiber or 32 by 8 fiber, just a standard fiber. It could do the copper as well. In this case, all 32 inputs of 12G could be frame synced. Or what's coming out in Q2 of next year, we're going to have an ability to produce 32 12G JPEG access encodes or 32 JPEG access decodes or 16 by 16 directly from the router. So that capability opens up a lot of different venues because, as you know, a lot of companies would like to interconnect their facility via WAN, like long distance, and JPEG access is a codec of choice because 2110 to move long distances is a big headache. You have to worry about PTP. A lot of people are using JPEG access. I mean, all the stadiums right now, I'm talking about NFL, I'm talking about NHL and basketball, they all have Lumen closets, so to speak. And those closets have our Scorpions with the Z21 MIO modules, which are producing JPEG access at, I believe, 370 megabits per second per each 3G stream. And that's how networks actually getting the signals directly from the stadiums. So we're adding this capability to the next router. So you have a fiber, we have a JPEG access encode decode. We also have a processing blade. We call it Next 670. We had the 670 as a separate card in a different frame forever. I mean, it could be SDI multiview, it could be 32 by 32 system to produce the actual IPG 2110 to SDI. It could be up-down cross converter. We just basically took the same FPGA, folded together so it fits in next router, and added this capability to the next router. So now we have an advanced multiviewer, which could be 32 by 8. It also has ability to do 2110 IPG directly in the next router, which you can do 32 by 32 3G or 16 by 16 UHD, or it could do 16 path up-down cross converter in the same blade. Going to the cross point, taking it from the cross point. Or 8 UHD up-down cross converter with both of them with HDR capabilities. So a very capable thing. Also, we've added capability of having a Scorpion blade on the same platform. And day one, we introduced the Dante, because Dante, pretty much in all new installs, people are using SSLs or different audio consoles, and Dante become kind of a choice for interconnect with the SDI network. So we already had the solution in the Scorpion world, Scorpion 4 with the 2 Dante cards, and then with the TDM going into the EQX or into the Next. Now we can actually receive Dante directly to Next router and have the audio capability there. We also have a Z21 system, which is second card from the left, and that card can have different functions. It could become up-down cross converter. If you don't need to do a bulk cross converting, you just put one card and it's going to give you a dual channel up-down cross. Or you can get HDMI in and out. In my demo, which is actually my guys, while I was away, shipped to Hawaii, and I'm flying there on Sunday. There's a Next 3 with all those 3 cards in it, and there's 2 blades of LM cores for Dreamcatcher and Bravo, which I'm going to be talking about in a second. So now I just wanted to give you some big announcement. At IBC, we finally announced our new router called ENX. ENX is the routing platform which is not SDI, which is not ST2110, which is not JPEG access, but all of the above. And it become more and more than that. So you have an enterprise class core, which now does have a cross-point redundancy. The next did not have a cross-point redundancy. The next router has a single cross-point, which you could take out and replace, and it would take approximately 7 minutes if you need to load the firmware on the new cross-point and if you need to get all your cross-point states back, because you have a industrial USB key connected all the time to your main cross-point, and if God forbid it dies, you just take the USB key, take the other cross-point and put the USB key in, and it has the firmware, it has the latest cross-point state, and it's all the multi-viewer layouts, all the licenses, so it loads it up, and then in about 7 minutes you're going to come back. Not everybody can live with that, so we needed to come up with a new version of EQX. EQX, which does have up to 3 cross points, full redundancy, people use it forever. So we introduced the ENX. ENX is the 512 by 512 18RU unit, which has up to 4 cross points. It also has cards, and there's a lot of similarity between ENX and NEX, and that's why I've talked about NEXT first. This time, you do have a full 32 by 32 fiber rear plate, or you have a 32 by 32 copper rear plate with a 12G SDI. All 12G SDIs could be frame synced. And this time, on this particular platform, the frame sync is not just plus minus half a frame. It's actually all the way up to 8 frame adjustment and up to 5 seconds audio. So it's a true little thing, and we're going to be adding some more audio adjustments capability on this particular router. But what is interesting on this router is the card which is underneath the coppers. That is a ST2110 card, and it's not IPG. It's not a conversion device. It takes ST2110 directly, it nuts it similar to SDI, introduces to the cross point, and from this point on, it lives inside the router as its own thing. We're also going to be introducing another card, Q2 next year, which is going to be JPEG Access, as I explained to you on the next router, which is going to be 32 in, 32 out, or 16 by 16. The 2 cross points allow you to have a full redundancy, but there's another 2 cross point capability. And the reason why there's 2 more cross-point capability, because now I can interconnect up to 3 of those ENXs together for a total of 1536 by 1536 12G capability. Or I can connect multiple NEX 5s. So have a central router in the middle and have multiple NEX 5s in different studios. And they're going to be interconnected with the 400 gig lines. There could be a 2-wire line carrying each of these 2 fiber line can carry 32 12G in, 32 12G out. So imagine what you could do with this platform. And as I told you on the NEX before, the NEX can become your processing device. You need to have an advanced multiviewer. Great, because ENX does allow you to do the standard multiviewers as well, which I was talking to you about on the NEX router. Very similar system. So you guys in engineering, and you would probably ask me, okay, how do you do that? It's not SDI. No, it's not. Inside of that, what we've done, we've learned so much by experimenting with, in the beginning with Aspen, then we were a big contributors to what 2110 is. But 2110 does have a lot of pitfalls. First of all, Dash 30. Oh God. I mean, who was thinking by allowing the Dash 30 be whatever the hell anybody wants to do? If you want to do 4x4 EVERTZ, do that. If you want to do 60 by 1, do that. There's so many different manufacturers uses different number of flows per normal audio per video device that suddenly you have to create another device which is going to groom it, which we do, Imagine does, like everybody does that, but why? Why would you do that? In the next, what we've done, we took the complexity out. We don't need to worry about PTP. We just use the blackburst. We don't need to worry about like different audio formats. It's always inside the NEX. It's always going to be leaving as a 16 audio flows per SDI signals whenever we're going to de-embed it and let it go. So it becomes a processing device. And whenever we take the ST2110 in our card, all we do is you connect your 2110 camera. Initially, you set it up. That obviously you need to understand that this is the IP address which is going to be received, and we NAT it. And from this point on, we see that as SDI signal. We don't need to talk to this camera. We don't need to talk to this camera. We don't need to talk to this graphics systems. We just see what's coming in to our router itself. It becomes so easy, uncomplicated, that ever since we announced it at IBC, I'm just flying all over the place, signing contracts because it's being installed. Like I have several orders already on the go for December. And then there's way more coming in after that. So it's a great little platform. So as the product manager, very bright lady, said 2110 made simple. You have any reference, distribute PTP through the frame sync, clean switch, no make before break, simplify routing, network translation directly on each individual port, no multicast source tables. That's a huge. I mean, people who do the actual engineering of ST2110, that's the biggest nightmare for them. No tuning of destinations, and it's a simple quartz protocol which pretty much everybody speaks. And then the audio shuffling is happening right on the core. And then similar, you have a monitoring with multiviewers. Multiviewers live on the 2110. So you have it's a built-in in the cards themselves. And if you need to have a complicated multiviewer, you just connect your NEX 5 with a bunch of different multiviewers with the FX links. That's basically, and it's all controlled through the Magnum using View as your front device. So you have a ENX, one core, ST2110, and the device. So we've talked about 2110, we've talked about SDI. Now let's talk about the other venue, how you can do the live production. There was a company, very little known company called Amazon Prime. They came to me with a problem. They run a very successful show. I've never heard of it before. It's called LOL, Laugh Out Loud. And this show is shot in Sweden. And for the entire summer, they hire the NEP truck and they do different languages. It's an unscripted show. The premise of the show, you have 12 comedians in the same room. You have a producer who is watching them like a hawk. And those comedians have to make each other laugh. So there's 40 cameras, 16 mics in Sweden, control room in Culver City. We come up with the idea of sending to Sweden a little flight pack with a 13RU 570 frame. That's with a 5782 XPSs. Each card can do 4 encodes. There's 14 cards in it. And then what we did, we encoded those ST2110 feeds coming out of NEP trucks, send them to the cloud. We also ask NEP to embed all the audio inside the test gen, which we also provided with 5700, and we send it via SRT to the cloud as well. But this SRT was coming faster over the ocean than the actual video. So we had a Dreamcatcher farm in the cloud, 40 ingests plus growing file. We had video mixer in Culver City as well. We had 2 replay stations. We had a Studer Vista Carbon, which was doing audio mixing. And for the operators, we had 3 little boxes. We called View Edge, the little mini computers with a Linux on it. They were connected to the AWS. They had HDMIs out for the touch screens and USBs for the keyboards, mouses, and as well for the touch screens. So we made sure that there's no latency in the Culver City between the video screens and everything else. So once again, Max switched to the website. So I'm going to show you what the show is all about. If it didn't. So this is, okay, audio if you can.
One common goal, try and make each other laugh.
So this is,
I'm ready to compete.
This is an epic battle.
Oh man, I'm laughing. But common goal, try and make each other laugh.
this is,
I'm ready to compete.
Myself.
Is that already too far?
How do you not laugh at that? Are you not alive?
There's nowhere that I'm safe.
Fortunately, I'm not a fan of comedy. I am in trouble.
So they're really watching. Yes, they're really watching. There's like 400 cameras in here. Let's keep it going, man. NHL star VK Saban in the house.
This is ever a delicious.
so what did we do? We built a system, and we designed a system. We created a very simple system, what we need to have it on-prem. That was a cloud-based system with a lot of components in the cloud. We had Reflector. The Reflector is our processing and orchestration platform. It allows us to replicate multiple unicast streams and send it to multiviewers, send it to Bravo to record it, and send to ingest farms, and to Bravo to actually switch it. We also had on the other side, in the Culver City Theater, we had some hardware. We had a full-size audio console, and we had 3 boxes, 2 panels, 1 big touch screen. So I'm going to show you basically what it looked like. Oh no, I can go back. That's how they make each other laugh. I mean, they're doing some ridiculous things, and then during the show. So this is the Culver City Theater, 8K big screen and theater with the 4 multiviewers on it, and that's at 4 o'clock in the morning because we had to do the show out of LA. So you have a first row with the audio and the PTZ cameras. This is the second row. This is your replay station. This is your video switcher. And this fellow, who was an old TD, he said, I'm not going to touch the touch screen. And we do have a Scarhoy button piano for him. Half an hour later, the Scarhoy was to the side, and he was just working on the touch screen. It was so easy for him to do. You can do the 2 boxes, you can do all kinds of different things. He absolutely loved it. So it was really a great experience to show that you can actually do the show not being there. So once again, it basically gives us a huge things. So it's definitely capable production way of doing. We did the prime time Thursday night football using JPEG Access. That was another POC we did. They did not use Bravo as a video switcher. and maybe because of that, they kind of postponed it because they had some issue with timing. The multi-viewers were showing one thing, and then by the time you press the button, 1001, 1002, TDs just couldn't do it. In our world, where Dreamcatcher actually ingests the things, and the same streams are being used for the Bravo station, you don't have that issue. It's actually immediate, even though you are 2 seconds away, because that's how much the flight between Sweden and LA was. In the actual environment, you were sitting almost like in an Obi truck. You were able to switch it perfectly. They liked it so much that right now we're actually in talks with them on doing several unscripted shows together. So it's really came out as a good representation of what you could do in the cloud. So just to give you an idea what the Bravo is, back switch to the website. I'm going to give you a little bit of feel. Oh, yeah, it's actually still working. Okay, so this is my Burbank office. It's not too far, but I've done this demo from Kazakhstan. I've done this demo from my Burbank office. It's not too far. No, you don't need to. You don't need to do my. It's just basically switching. So what I'm doing right now, I'm just, if I press on the right-hand side, as you could see, it switches the program. If I go on this button, it actually switches with the slate and goes in the 2 boxes. If I do the take through transition, I can change the transition, and it's easy to actually adjust the transition. I can do the transition ridiculously low or ridiculously high and just do this transition again. I can also take it quickly, and I can change what's going on here. I want to do this video here. I want to do this video here, and I take it. I can quickly switch to soccer and work it too. On the second screen, I can do different graphics. I can put the graphics in. Let's see if it's, yeah. I can take the graphics out. I can put these graphics in. Actually, I'm going to put several graphics together. Take it out. So this is just an example of very small system. We have a system which actually has 40 UHD in and 6 UHD out. And we'll come back to it in a second. But before we come back to it, I'll go back to the system here. So the customer I cannot name has probably the largest Bravo install in the market. It has a 40 UHD coming in and 6 UHD coming out. There's a program preview. There's a second ME, if you can tell it, to do the social media vertical. And there's some other stuff. We also use Next routers to interconnect to existing Next router, which we've installed a couple of years ago. And this particular studio is fully EVERTZ, and it's not ST2110, it's 12G SDI in and out. This is our Bravo and Dreamcatcher system. So we do have capability of replay. We also have a capability of switching different things. And they went on air just recently, and it was a very exciting thing. So I'm going to switch back to my video. And I'll just do this without saying anything else. You can take the video out.
1. Eagle switching downrange. Booster Raptor chamber pressure nominal.
Booster and ship, nominal power and telemetry.
All right, we are about 45 seconds into flight. We're still getting the rattle here at Star Factory. We are seeing 33 out of 33 Raptor engines lit on super heavy as it arcs across the Gulf. Coming up next on Max Q. Got 6 out of 6 Raptors lit. We're also going to separate the hot stage. This will be the final time. Ship Raptors are going to continue. So you can see the hot stage. Booster comes back for its landing burn.
5 to slow down the booster for landing. And finally, that will come down to 3, and we'll cut all of them off while we're still about 200 meters in the air. So booster is gonna see a bit of a hard
Booster landing, we'll start it. Booster landing, burn shutdown.
And there we heard it, booster landing burn shutdown. We saw a 13 to 5 to 3 V3 demonstration, and into the water we go. Wow, that was absolutely awesome. If you can even hear us right now.
So we are on the path that we want.
10 minutes. All the objectives were met on the booster, including that V3 style landing burn. So now going out.
worth repeating. Starship will deploy Starlink.
3 down to 2.
Starship has landed.
As we said, we're not planning on recovering the ship.
Many different things. I didn't say who it was, but EVERTZ does produce all kinds of ways of making the live production happen. You've seen it in ST2110, you've seen it in 12G SDI, you've seen the use of the newest way of live switching, and I'm open for questions.
Hi, there's a question from the field here. Does NEX play well with Cerebrum VSM as a control system?
Through Magnum, yes.
Through, oh, okay, through Magnum, instead of Magnum, though.
Well, hold on, not necessarily, hold on. With NEX router, it will definitely work without any Magnum in the middle because NEX speaks Quartz protocol and Cerebrum speaks Quartz protocol too. If you need to talk to ENX, which actually has a ST2110 component to it, no, you would have to have Magnum.
Okay, thank you.
Any other questions, comments, input? All right, our next meeting is November, I believe the 17th. We'll have Shure in. First, let's, give a round of applause for Max.
Thank you.
Yeah. And we'll talk about microphones next month. All right, thank you, everyone.
Thank you.
Hold on.
Try something. I got Paul Chapman waiting outside. See if we lick this. Sound check, by the way, is at 6:30. So hang on here. We got to find him in his. We have, by the way, we have 16 still on. We had 20 on the remote Zoom. And I'm trying to find Paul Chapman in the, here we go. I'm going to ask him to unmute. I want you to, Paul, will you?
Hello. I'm here.
Paul Chapman?
Hello. Hello, hello.
I think he's asleep. Okay, John? John
I'm
Scheid,
here.
are you still with us?
Audio's not working.
Oh, there he is.
I'm talking.
Audio doesn't work.
This should have happened at 6:30, but we're trying to.
Oh yeah, I saw one.
Next time.
Okay. The sheets were all rolled up in a ball, in a comforter and all that. And it was a big ball. I was like, oh, I gotta fix that hose. I gotta do it. I just have to cut the thing. I know. I air dried them and I hung them up.
Hey, Eric, you're talking. You're unmuted.
Because it's still this way.
Oh, wait a minute. Who's
Oh yeah, yeah.
So it's not gonna be any better.
It's still gonna do the same thing. It doesn't go back and around and back. I plugged my car in because I have zero power. So
I got people who unmuted themselves. Okay. So this can actually work. One day, I guess we'll have a remote presentation. We can hear you in the house here. Can you hear us, Paul?
I can hear you. I'm
All
here.
right.
Yeah.
All right. So next is John Scheid, who had something for the mic pass. But
Well, I just real quick, at the SMPTE conference, I think it was a great summit last week, and just delighted that we had 142 students, including 30 students from Cal State Los Angeles, who put together a control room and put together a 1-hour program on October 16 that was part of a 26-hour program that started in Australia and finished up. The last hour was at De Anza College in Cupertino, and then finally Los Angeles, done all by CSU LA. So Jim DeFilippis helped pull that whole dang thing together. So hats off to Jim.
all right. There's applause
Yay.
in the room, John.
Cool.
Okay, and I guess with that, we're going to end this Zoom.
Many thanks, guys.
Okay. Bye all.
Take care.